Hello, dear aquarist, dear marine fish hobbyist or breeder or specialist. Today, as you might have seen in the title, I will talk about Oodinium or velvet disease in marine fish and a study that has been done, what the effect can be with salinity and what impact it can have on those parasites. That might be an interesting help into control, especially when you're a breeder or when you're an importer. That salinity can be an interesting help that might prevent the use of medication or other tools that you want to use. So a very simple solution is not always so easy to find, but it gives you an idea what you might try out by implementing salinities in treating Oodinium. So I will share you the study and the background. As you can see, I share you my photograph that I took during my snorkeling in the Maldives in February 2025. Lovely to see healthy marine fish in the nature in a very healthy environment. So here is the study about an outbreak of Amyloodinium ocellatum, which is the velvet disease of marine fish, in broodstock of the Java rabbitfish, Siganus javus. I will show the link or write the link below so you can even find yourself that study. You want to go more in detail on certain facts, but here I will describe the most important facts that I think I would share with you as a fish doctor, which can be practical when you keep or breed marine fish in our ornamental aquarium industry. So to give you a little detail what it's all about, it's in the abstract about an outbreak of an infectious nature in captive stock of Java rabbitfish in brackish water tanks was investigated. So these fish live in brackish water, most likely, that's how they've been kept for breeding. And the microscopic examination revealed different stages of the parasitic dinoflagellate Amyloodinium in the gill filaments of the moribund fish. And the histopathological studies confirmed severe infestation with gill erosion and lamellar fusion. Well, we know that Oodinium is badly affecting the gills, and that's why the fish eventually will die. The salinity requirement of the isolate was assessed by incubating tomate stages at salinities ranging from 0 to 30%. And the salinities below 5% were shown to inactivate and degrade 90% of the tomates within 14 days of incubation, whereas the salinities above 10% supported the parasite life cycle and its development. Further, they did a study on the susceptibility, I mean, how easy can Asian sea bass, lattes, also get the Amyloodinium or velvet disease. They did a challenge study. So they did, in fact, here two studies on this velvet disease. So I will not go in detail in the introduction about the sampling because it was all about the brackish water, a breeding tank, they selected fish. I will not go in detail about the DNA extraction, etc. But to start with, is about the salinity test they did, and they collected the parasites, the tomates, were collected by exercised and placed the infested gills. They put it in sterile seawater, and the tomates that were adhered to the gill lamella were gently flushed with a sterile phosphate buffer saline using a pipette, and free tomates in seawater were also collected and rinsed twice and collected. And the tests were done in different, how can I say, different salinity waters from 0, 5, 10, 15, 20, 30% salinity in 30 degrees Celsius. So they did it in a laboratory testing. They didn't test the fish, but they took the parasites, collected them from the water, collected them from the gills, and they were the treatment with intervals of 2 days, and they were observing what happened after 40 days when we did that salinity test. And the other test they were doing, that was an experimental challenge on the Asian sea bass, the lattes, and the two fish were kept in a few fish, well, 10 fish in 6 tanks of 500 liter with a salinity of about 30% and a temperature of 28 degrees Celsius. And they were fed twice a day, 2% of their body weight. And the tomans, the parasites, were added to 3 of the fish tanks. So the other 3 tanks, which didn't receive the parasites, the tomans, were the control group. So we will see later on the results. First of all, the infection on the Java rabbitfish. Well, the fish had some whitish, cloudiness, peppered look on their skin. And you can see here on the right the gills. You can see how badly they infested are with all those parasites. And here you see microscopic observations of the parasites. Also here the division of the tomans that is happening. They divide sometimes the tomans, and then eventually they will develop as trophons to reproduce. Here is a magnification of the tiny dinoflagellate that spreads to reinfect the fish. Well, the results, well, they checked on the fish, weight amounts were taken, Oodinium were collected. They took samples of the pathological tissue, they examined the gills. I will not go in detail, we know they are attached to the gills. If you use a microscope, well, you know how it looks like. And the interesting thing for us to discuss today is the effect of the salinity. And well, it revealed here in detail that different salinity was giving different results. And I go right away to the table, which they pronounce here as figure number 9. It was a little bit awkward in this article. That this figure 9 was way back in the article. And here it is. Here it is. Figure 8, figure 9. And here we could see that the salinity of 10 to 15% salinity did show no incubation of tomans at 14 days. And that was for me the interesting part, that those brackish waterfish, if they keep them at 10 to 15% salinity, the tomans are really reduced or zero, absent. At higher salinity, well, we know Oodinium, the velvet disease, thrives very well at higher salinities. But even at the very low salinities, there were some parasites left. I think that might be due to the stressy situation, that the fish were stressed, and stress is causing lack of immunity, and that the Oodinium had a better chance to remain adhered to the fish. But particularly interesting is to understand that 10 to 15% salinity would be a very good tool to control marine velvet disease. Here in the microscope, you could see that A and B, the tomans were degraded, and here at the salinity at 0%, they were degraded, they were damaged, they were still there. And at higher salinity, they were still perfect. That's what the microscope revealed about this salinity test. If we did examine the experiment they did with the sea bass, So they inoculated, they added parasites to 3 fish tanks with different salt levels. And they had 3 control groups which did not receive the parasites, Oodinium or Amyloodinium or velvet disease. And you could see after 28 days, the fish all died in those 3 tanks. And here below, the level here below, you can see here, this is the control groups. There was no mortality at all. So adding those parasites in the test revealed that, look at the gills here to the right, were completely loaded with parasites. The gill lamella were affected, fused together, and the fish died of, well, of a lack of gas exchange, lack of oxygen. Well, the conclusion was in general that in the beginning of an infection of Oodinium, you should try to use freshwater dip treatments when it's possible, difficult when you are, in my opinion, a breeder. In a close aquaculture system, you might try, but I would recommend, like here in this case, to lower the salinity to 10 to 15%. And that would be interesting when you deal with marine fish, you import marine fish, or you are an exporter and you receive the marine fish from the wild, that you'd keep them for a certain time, depending on the species. Some species are more vulnerable and more easier affected by lower salinities. You have to watch the kind of fish you're dealing with, particularly the very flat fish are very easily affected by lower salinity, the osmotic pressure, while the round fish can easily live with very low salinity for minutes and hours. So those treatments can be very effective in using 10 to 50% salinity. They also talk here about the possibility of vaccination. Of course, they have to talk about vaccination, but also the article and some references in the article also state that when fish had contact with the oodinium during life, they built up a natural immunity. So interesting to think about fish giving a chance for natural immunity to develop that, to work on that, so the fish can defend itself on nature instead of messing around with vaccines or messing around with medications. Important, of course, dealing with oodinium is planning good biosecurity, preventing that the spreading of the disease goes around. I have different articles, or I mean, YouTube videos on that thing. But in the quarantine phase, use lower salinity. You can look at more references if you want to read more. But to conclude my talk about this experiment I did, collecting the parasites, oodinium, and in a laboratory culture checking how they survive in salinities, was very interesting for me to learn that, like I also mentioned in my books, that salinity, freshwater dips, can be very helpful instead of medications, particularly in the beginning stage. When it's too much advanced, well, you might have secondary bacterial infections because the damage done by the parasites gives a chance that bacteria also invade in the gill tissue or even in the skin tissue. They also can appear there, those parasites. Here they collected them from the water and they collected them from the gills. But anyway, think about salinity. 10 to 50% when you breed, when you put marine fish in quarantine. And you can do it for a certain time, maybe several days or week, maybe, depending on the species. Like I said, flatfish with a high contact, high osmotic pressure will suffer more than a roundfish like a clownfish. Clownfish will do much better in lower salinities for a long time, or even freshwater baths. So I hope this video helped you a little bit to understand what you can do treating with Oodinium. Thank you for watching and subscribe and listen to my other studies when you learn more, want to learn more about fish diseases.